So take this example to find out the shortest path from, let's say, from source A to B, C, D, E. So Dijkstra algorithm works well even for directed graph or undirected graph, and it is completely based on which approach? Greedy approach of programming. Means what? Whenever we are trying to select next node or next cost, then always we are greedy about shortest path. So this is completely based on greedy approach, and it is far better than Bellman-Ford. Bellman-Ford algorithm is little bit slow compared to Dijkstra algorithm, but Bellman-Ford algorithm has advantage as it works well also with negative weight. Although Dijkstra, as I have told in the first part of this video, that it may or may not work good for negative weight. So for these questions, for this example, I am not taking any negative weights in this directed graph, but even I will show you in next part of the video that taken a negative weight, it sometimes it may gives you correct answer, but sometimes it may not give you correct answer. That's the reason people always states the Dijkstra algorithm works well only with positive weights. And if definitely there is cycle of the weights and some of the weights of the cycle is negative, definitely answer is not correct in case of Dijkstra also, as well as for Bellman-Ford. But Bellman-Ford supports what? Because that is based on dynamic programming approach, and that supports negative weight, but Dijkstra normally does not support negative weight. So let's take this question and how to solve this kind of question. Basically, a source will be given to you and based on the cost matrix. So normal, what is the method we use for relaxation? That concept is known as relaxing. Relaxing is nothing if the distance of u plus cost of u to v. U is my source vertex. Let's say this is my u and this is my v. So this is my distance. Current distance of A is nothing. Self distance is always 0. And rest all distance at the first instance is nothing. It's a infinity. So even C is at infinity, D is at infinity, B is at infinity, and source self distance is 0. I will try to find out the shortest path starting from my source. So distance of u plus cost involved from u to v, that is C of u to v. Let's say it's a 10 here. If it is less than current distance of v, if it is less than current distance of v, right now it is infinity, then definitely distance of v will be updated with distance of u plus cost of u comma v. So that is the formula. If distance of u plus cost of ub is less than dv, then definitely distance of v will be updated with distance of u plus cost of ub. So this method is known as relaxation in case of Dijkstra algorithm as well as in Bellman-Ford. So we will be taking only this formula for updating our distance matrix from source to destination. So first of all, how to solve this kind of questions we will see step by step. So we'll draw one table, and in the table you will write down all the nodes or vertices of your graph starting from my source vertex. So my source vertex is A. In the question it may be given B, C, D or E. Whatever source vertex is given to you, you first of all mention about that vertex, and later on you can write in any sequence. So let's say I am starting with A, next vertex will be B, C, D, and one more vertex we have, that is A. Initially I have suggested you, self distance to A means distance of node A to itself is nothing, it's a 0. And for all other nodes from A to reaching to all other nodes, we will take distance as infinity because we cannot reach right now. Now after this initial step, one column which we have added at the first, that is known as selected vertex. And what vertex we are selecting right now? Right now the shortest distance vertex. So out of all these infinity, which is the shortest? 0 is the shortest, so we will be starting with A only. Fine. So this is the selected vertex right now. Now from selected vertex, whichever is minimum, Here it is 0 is minimum, out of infinity all others. So 0 is minimum, we selected. From this minimum selected vertex, we will try to update its connected edges. So what edges are connected? A to B. We will check what is the distance of B. Right now distance of B is infinity. Cost of reaching from U to V, from A to B is 10. And what is the cost, distance of U? That is 0. 0 plus 10, which is always less than infinity. So what I will do, I will update the distance of B with distance of U plus cost of UV, that is 0 plus 10, because 0 plus 10 is less than infinity. So B cost reaching to B is, now we are getting a better path rather than infinity. We can reach in a cost of 10. So we have maintained like this. Similarly from A, in order to reach C, there is no direct path. So you cannot reach C. Yes, you can reach C here by with a cost of 5. And right now its a cost is nothing. It's a infinity. So 0 plus 5. So you can reach C with a cost of 5 here. Fine. What any other vertex we cannot reach directly from A here. So these two matrices you have updated in the table. Now out of these two, you will select the minimum one. Which one is minimum? This one is minimum. So this vertex now you will be selecting in next state. Okay. So now from C, we will try to find out to other vertex where we can reach and its cost is less. So from C, we can go to B. And right now cost of reaching B is 10. But if you go through this, so cost of reaching to C is 5. This is 5. So this has been maintained with 5. 5 plus 3. So this can be updated with A. So B can be reached with a cost of 8 here. So we can update. Similarly from C, reaching D, right now cost is infinity, but we can reach with a cost of 5 plus 9, 14. So D can be reached with an updated less cost 14 compared to infinity. So we can maintain 14. And similarly from C to E, right now cost is infinity. So 5 plus 2, we can reach with a cost of 7. So this much we have got after this step. Now out of 8, 14, 7, which one is minimum? E is minimum. So we will be selecting new vertex. A already been selected. Whatever vertex has already been visited or selected, we will not revisit again. So similarly C will not be revisited again, means its cost will not be updated. Similarly E will not be updated because now in this step we have selected as E. From E, what update we can do? Till E we are getting a cost of 7 here. So this has been updated with 7. From E reaching to D, it may take 7 plus 6, 13. But right now D has a cost of 14. So it can be updated with a cost of 7 plus 6, 13. So D can be reached with a better cost, that is 13 here. From E, we cannot go back to A. Reason being, A is already been visited here. So although path is available, but we cannot update that path. Once you have visited a vertex, you cannot come back. Similarly from E, any other path you can reach? Nowhere you can reach. So this is a new cost you got. 7, 8 and 13. Out of 8 and 13, which one is minimum? So this one is minimum. So next time we will be selecting B here. So from B, right now cost is 8. And if you are maintaining 1 here, so D can be updated with a cost of 9. So out of 13, now you got a less cost to reach D through B. So you have updated like 9. Any other place you can reach? You cannot reach any other place from B. Rest all vertex has been updated or visited. So now you can see 9 is the only one and that is the cost of D. So from here, now you have visited all the vertex. And whatever I have highlighted here or selected at a particular instance, this gives you a cost of reaching to that vertex from source vertex. So you can see A to A cost is coming nothing, it's a 0. It's very much correct. If I want to reach A, my cost is 0. If I want to reach C, my total cost of reaching C is nothing, it's a 5. My total cost of reaching E will be nothing, it's a 7. My total cost of reaching B, A to B, is nothing from source, it is 8. And total cost of reaching to D, A to D, is nothing, its total cost is coming as 9. So this is the cost matrix from a source A, how much cost it will be involved to reach any other vertex in the given graph. And the graph is either directed or undirected, this method will work very well. So in order to find out, this is the cost matrix or cost of reaching path. What is the path? Let's say you want to calculate the path to reach D from A to D, although you know cost is 9. But what is the path? So we will go step by step backward. So in order to reach D, we will make a pointer, let's say here. We will go one step back. And if we are getting any change in the cost of this, we will move to the selected vertex. Which vertex we have selected in this row? So we can see from here that we have selected B here. So in order to reach D, we must have visited B. So first of all, in order to reach D, we must have visited what? B here. From B, again there is no change, no problem. Again you see there is a change in the cost matrix here, and that happened because we must have visited C before. So C will be selected in the path. From C you can see, come back to one step further, you will see there is a change in a matrix or cost matrix here. So which vertex was selected? A was selected. So path, in order to calculate the path between source A to destination D, what is the path here? We will go from A to C, then to B, and then to D. And you can see the total cost of reaching A to C is nothing, it's a 5. And from C to B, how much cost it takes? 3. C to B is nothing, it's a 5 plus 3. And from B to D, you can see 1. So 5 plus 3 and plus 1. The total cost you can see, you can get it here, 9. And what is the path here? From source to destination, A to C, you just write in a reverse way. Whatever I have suggested you. You go step by step. And if there is any change in the row, you choose a particular vertex that was selected. And then come back one step further. You get no change, no point of selecting any vertex. Again you got a change. Which vertex was selected here? C was selected, so I have mentioned here C. Again this value were made change. This is just because of A was selected. So this way you could write path here. So path of reaching A to D is nothing. It's basically A to C, and then C to B, and then B to D. So this way you can solve the problems simply by using this table, getting the cost matrix, as well as writing the path of reaching that matrix. So this is the first example I have told you, and this is for directed graph. I will tell you one more example related to undirected graph also. I will tell you one more example related to negative weight if it is given in the question, and whether Dijkstra works well or it may not works well. I will tell you that example also. Then we will move to better version of Dijkstra for finding single source shortest path, that is Bellman-Ford algorithm. So for this question, I think I hope based on simple this relaxing matrix, you can simply make this updation table and you will get the cost matrix here. So that's all for this particular question. Thank you.